Hello, hello everyone. Welcome to this afternoon session on JavaScript code. Maybe it's not clear from the title, I hope it is, but this will be a discussion, a talk about asynchronous code in JavaScript mostly. I am Jerry Deboni, I am the JavaScript framework team leader, and so I've been working at Odoo for the last 10 years now, and during those years, I learned a few lessons on writing asynchronous code properly to be performant and to be correct. So we will talk about that today. But I understand that this is a technical talk, technical topic, so it's probably quite boring. I suggest you can look at those two talks, and they may be more interesting if you want to. OK, so when I started working at Odoo, I actually didn't know I would work on JavaScript code base. And I kind of thought about JavaScript that since it's single-threaded, there would not be really any race condition. I knew about asynchronous code on the server side, but in JavaScript it was not the same, so I didn't expect that to have so many problems. So I was quite surprised when, like 10 years ago, or 9 years ago, we had some kind of interesting issue. If you look at this, it's a true story. This comes from the invoice form view. And what happened, we had in our own accounting department, we had some invoice where we had twice the tax applied. And after a short investigation, it was obvious that it was just because the accounting person would double-click on the button, validate. I don't remember which button, but it was just essentially a double-click issue that triggered multiple requests to the server, which in turn would apply twice the tax on some lines. So obviously, this is a problem that should be handled on the server side, but it should also be handled on the browser side, because if you understand your user, they would always double-click anyway. Many of them will. So you should be safe. So that's what this talk is about. So when I'm talking about asynchronous code, what kind of situation leads to asynchronous problems? And we have obviously all those network requests. Network requests takes some time to talk from the browser to talk to the server, and for the answer to come back. So it takes some amount of time. But it's not the only case, the only situation where we have issues. You may have some user interactions that will interact with your user interface and may cause issues as well. Maybe some widget or some component will be destroyed while it was doing something. I don't know. You also have some animation or some transitions that could be visible to the user. So what should happen if the user clicks on a button that is disappearing? I don't know. It depends. You also have asynchronous rendering. All is asynchronous. So when your component is rendered, it's not visible yet to the screen. It will be visible a few milliseconds later. And in that window of time, it could happen that some requests come back, maybe some state is changed, and your screen may crash later. So that's a possible source of problems. And also we have all kinds of problems with intervals, timeouts, debouncing, throttling code, a lot of asynchronous stuff going on. So really the true root of the problems are that actions and events may overlap, may interleave. So we have here an example where we have 3 clicks. The user may click on 3 different menu items in the web client, for example. And the first click would load some action, I don't know. Then the second click would load another action, and the last would open a menu. What would you expect to happen then? What would the user expect? Most likely that its last click would be visible and would lead to the last menu that he was trying to open. But in truth, you don't know the order of the requests when they come back from the server. They may take some random amount of time. That's the way you need to think about them. And they may come in a different order. So in this case, if your code is badly written, it could happen that the click to, the second action, will be displayed instead of the last action. So that's one possible way. You could try to serialize all those requests. But if you do that, you will see the first action, then the second, and then the last one. And maybe it's wasted work. So you need to be careful to be performant, and at the same time, you want your code to be correct. That's what this talk is about. And I will explain a few common problems, and we'll try to give tips on how to solve them. And then we'll discuss concurrency at the end. So first, user interface issue. The main problem that you will have is quick actions in a quick succession. So, for example, double clicks. So imagine in this case, we have a button on which you can click, and it would print some report. That takes some time. And if you have just a naive code like this, the user may double click, and you will get in return 2 reports. That's not what you want. So how do you solve that? There is really a common solution, and it's to use some kind of debouncing function. We have one in the web client. It can be imported from web core utils Taming, and that debounce function will basically only apply the first action when it's done, and any subsequent action for a period of time will be ignored. So that's the point of this. You just need to be sure that you cancel all pending action when you unmount your component, or otherwise you may encounter some trouble. And to do that in an easier way, you can use a specific hook that you can import from web core utils Taming again, and it's called use debounced. And really, it's like the main function that you probably want to use if you want to debounce some user actions. Okay. Now, maybe debouncing your button is not what you want to do in some cases. For this case, what you can do, it's another possible solution, it's to disable the button. So you just make sure that if you disable synchronously, so immediately, the button when the user clicked on it, then there is no way to click on it again until it's enabled again at the end of the request in this case. So maybe it's more in line with what the user expects. It would be weird to have a user click on your button, then wait some amount of time, click on it again, and be able to print 2 reports like that. So that's a possible way to solve the problem. That's actually what we do in the web client in a different way. You need to be careful to re-enable all those buttons when your component, if there is an error or some kind of crash, you need to make sure that everything is re-enabled again. But that's just some polish that you can add afterward. Okay, so that was really the main user interface issue that I wanted to talk about, because I'm more interested in what comes next, which is very common to see in the pull requests that we review in my team. We have performance issues. And really, you need to think about network requests as very expensive. Maybe imagine that for each additional request that you introduce in your code, maybe like 10% of your salary will be deducted this month. So that's really very expensive. It takes some time to talk to the server. It takes like half a second, maybe less, maybe a little more. It depends. But it takes some time. So you need to reduce as much as possible the communication between the browser and the server. And really, that's a never-ending kind of work to reduce such a communication. So the first lesson on that is to say that in some cases, you can even avoid doing requests completely. So for this example, we have maybe some components that need to load a very simple configuration elements, configuration key. I don't know, something that is not meant to change a lot. And that code will perform, if you look at this, the way I made it on will start, that code will be executed every time this component is displayed. So maybe it's fine if it's displayed just once, but if for example, it's in a view, your user will load that view, that request will be done. Then when later it needs to come back to the same view, it will be done again. So the best way to solve that problem is to just not do any request at all. And you can do that by embedding the data, injecting the data inside the HTML page itself. And there is a way to do that in Odoo, something that you should avoid to do for something that is expensive, but it's fine to do if you have a cheap, small pieces of data that you need at all time. And you can just add this data to the session. You need to override the HTTP controller. There is a session info method that you override to add your information. And then the JavaScript code can read that information back from the session object. So it works, it's nice, but most of the time you actually need to load data, really. For this example, you may have a dashboard. This dashboard will load a lot of data. I don't know, it's expensive. You don't want to put that data inside the web page. So if you look at this code, again, it's a naive example. Your data will be loaded every time your dashboard is displayed. And maybe, for this case, we can say that it's fine if the dashboard displays some data that is 5 minutes old, 10 minutes old, or even 1 day old. It's just a dashboard. You just want an accurate representation of maybe the daily operations, but you don't care about being real time. In that case, what you can do is to only load the data just once. For example, you can lift the state in the service. So not you should not keep your state in the component itself because it will be destroyed and recreated again at a later point. What you want to do, maybe, is to move that state inside the service and to load that state just once. This is done in this example with a memorize function that will just execute its inner callback once and then use that as use the result as the answer for the next time it's called. But you can do it in many different ways. You could even invent a system where you have a cache system that will be cleared after a set amount of time, maybe 1 hour or even less, I don't know. So the point of this slide is to tell you can try to just load your data just once, and already, by doing that, you reduced the amount of communication that's required between the server and the browser. Okay. Now, sometimes it doesn't work, and you need to load multiple values. In this case, we have a piece of code that will perform two requests. And if you look at that, you can see that they are doing it sequentially. And that's not really efficient. If you do that, you need to wait for the sum of the amount of time that each of them this request takes. And you can do it much better. So that's not really specific to Odoo, but you can do it much better by using promise.all, which will do that in parallel. Okay? So that's a very common problem that you can solve very easily in that case. Now, last tip that I want to give you is that you can sometimes load a lot of related data in one step. In this case, we have, let's say, 3 requests. We fetch a record, then some x2many fields, then some many-to-many tags inside those fields for some reason. And it's not independent, so you cannot do those requests in parallel. The way you can do it in a better way would be to use either our web read method, which can allow you to read nested data in just one request, or maybe you can create your own custom controller that will aggregate all the data that you need and send it back in one step. So that's one way to solve this problem. Now, I have time is running out, and I want to talk a lot more about concurrency issues. So that's really the main difficult part of asynchronous code. It's how to coordinate code that performs multiple actions at different moments in time. So let's take this short example. So we have a form view model, some code that will load a record that can update some data inside that record, can send a message. When I meant load a record, I meant load the data and some message. For example, imagine some chatter messages. Okay, and our model can also save those data to the server. This is a naive implementation of what it could look like, and we can see that there are many issues with that. Let's talk about them. First, the loading code is sequential. If you look at that, we load the data and the messages. Fine, that's easy to solve. we can load those data in parallel. That's what the slide, the black part is doing. We use promise.all. We send those two requests, and then we wait for them to be completed. Nice. Now, we have another problem if you look at just those two methods, load and save. And the problem comes if you perform those operations in a quick succession. Imagine that you load some record with the ID 3, and then you save the record quickly after, before the loading operation was done. And if you do that, if you notice, when you start loading the operation, we set the ID as an instance variable, and we use it in the save operation. So if you do what I'm saying, load and then save, you will save the previous record data to the next record. That's probably not what you meant to do. In that case, you need to make sure that you solve this inconsistent state, because there is a period of time in which your model has some ID that does not match the state that it's holding at the same time. So to solve that, you need to be sure that you can perform those updates in an atomic way. You want to move the ID, the line that sets the ID at the end, so it will be executed at the same time as the lines that set the data and the messages. And really, it's a kind of a simple example, but that's a very, very, very common issue that you will encounter in code. Try to make atomic updates instead of setting your own state partially and then later setting some other piece of state. Okay? Now, there is another issue. Let's talk about that setMessage function. If you look at this, it will send a message and then push the message to the local list of messages. And what happens if you send quickly two messages? You send the first message, and then the network request could take some time, and then you send quickly a second message, which, for some reason, the network request takes less time. In that case, the messages will be pushed in the local list this.message in the reverse order. And that's very common if you implement a very simple chat application. That's what you will see. So how can we solve this? We can coordinate those actions. They were not coordinated, they were like just doing in a naive way. Now we want to serialize them to make sure that they will be sent in a proper order. And that's what this code is doing. We use a mutex, so something that you can import from the web core utils concurrency file. And you need to create one mutex for your form model, and then you will send all those operations through the mutex. And by doing that, it will be less efficient because those messages will be serialized, but it will be correct. They will be managed, handled in a proper order. And that's really a common theme of doing concurrency work. If you want to be efficient, you will probably lose some correctness unless you're very careful. So let's talk about one other issue that you may encounter. If you have the load operation done quickly in quick succession, or maybe if you have a save and you update some data and then you save again, you will have the same problem. Again, to solve that, we need more mutex. Basically, we need to mutexify everything, and that's what this is doing. I use the mutex in the load operation, in the send message function, and also in the save operation. So we're making some progress, but is it enough? If you do that, you will see that, of course, those load operations are sequential, and that's not what you want to do most likely. You want if the user is clicking next quickly, you want this operation to complete faster, and you want to basically ignore the first load operation and send the second load much quicker. And to do that, I want to introduce you to the keepLast concurrency primitive, which is imported from the same location as the mutex. And really, what the keepLast abstraction is doing, it will just ignore or leave pending all operations that are currently being done whenever you add a new operation to the mutex. It takes a promise and not a function, but it's kind of similar to the mutex, except that it will be faster because it will not wait for the first operation to complete. So this is you would do that in the context of reading data, not in the context of updating data. Now, this is a comparison of what it could look like. If you use mutex, it's slower, but it's safer. And if you use a keep last, you will ignore the first operation and start the second operation quicker. Now, are we done? Of course not. If you look at this, we have one more issue. The data that we send through the mutex is not necessarily the same at the time the save action was initiated. So to do that, we can capture state in the closure. And that's the difference between those two pieces of code is that in the first one, you send the data when the operation is started. And the first one, in the second one, the solution, what you do is you capture the ID and the data. And in this case, we even clone it to be sure. And then we send it to the mutex. So that's another kind of technique that you can use to have consistent operation. So now, are we done? What do you think? Of course not. The fact that we changed mutex into keep last in our previous slides introduced many problems. And actually, if you look carefully at this model, it's still not safe at all. And that was the point I was trying to tell you, is that writing efficient and correct code is very difficult. So that's your homework for today. You can take the code that I showed you and try to make it concurrency safe and efficient. Good luck to you. Now, thank you for your attention.
Hello.
Hello.
Thank you for this very interesting presentation. So we have some questions. The first one is, for consistency, isn't better to keep the state in closure instead of class variable where they can be modified?
Say it again.
For consistency, isn't it better to keep the state in closure instead of class variable?
Oh yeah, okay. So the question is about always using state variables. We use a model as classes in Odoo most of the time. For example, this is a class, and it's very useful. It's not as safe as using closures, because you can modify that state from the outside, but it's really the way Odoo works when you can extend or patch a model from the outside, and you can then modify that state. And it's something that we want in some case. So yeah, it would be safer to use closures, but it's not what we want to do in some case.
Okay.
So.
Thanks. Second question. Isn't fetching all data in one step sometimes slower? Because the server is doing sequential works. With multiple requests, we get more parallelism.
Yes, that's true. So this is something about the fact that you could fetch all data in one step. And if you do that, basically, you minimize the amount of communication that your code is doing, of course. But what happens then is that the server will do a lot of work in a sequential way in one thread. So yes, it would be slightly slower in some cases. So you need to be careful and to understand why.
Okay, thanks. Are there plans to improve the readability in general of the ORM library to make it easier to work with?
The readability, I'm not sure if you're talking about the readability of the whole code itself. It's done in TypeScript, and I think it's OK. So we don't plan to change that really. But what we plan to do is to add a lot of onboarding material to make it easier to learn OWL itself.
And how about TypeScript?
Oh, I would love to write the JavaScript code base, to rewrite it in TypeScript. But for now, only side projects are allowed to use TypeScript because they use their own build system. For the main code base, we don't use TypeScript at all. But what we plan to investigate is maybe using more and more those doc strings to get at least a nice auto-completion. And maybe we can even type check our code base using just the JavaScript code.
Okay, there is another question. Where is the code? I don't know. It seems quite general.
I'm not sure what code you're talking about. So the code for this talk, you can look at the slides, maybe, or you can ask me. Maybe I can share the slides on the pad soon. Or otherwise, if you talk about OWL code base itself, it's in our OWL repository. And the code that I mentioned a few times, let me talk about the mutex quickly. For example, this web core utils concurrency it can be found in the web add-on in the static src core utils concurrency.js file. So all those comes from the web add-on.
Okay, that's all for the question. Thanks a lot.
Thank you, everyone.